Welcome to Helpful Hints for 1033 Lab Project for Chapter 6. We'll explore work problems in this chapter. We're going to be looking at a few things here. I'm going to be talking about rates. So Joe can paint one whole house in 3 hours. That means his rate per hour is a third of a house. So we're going to identify that we use the 1 over whatever Joe's time is to complete the whole project, and that's going to be the rate that we use. So this is the format that we use. The 1 over the first worker plus 1 over the second worker is 1 over how fast they're working when they work together. And we can use this to find the numbers. Now what's going to happen is we need to find the LCD, and then we clear the fractions. Clear the fractions is a vocabulary term that you're going to see a lot in Chapter 6. So identify what your LCD is. What is the least common denominator of 3, 5, and x, and then multiply through by 15x. That should clear all your fractions so that you don't have any denominators left over. And then you can solve algebraically, continue to solve algebraically. But clearing the fractions is a process of multiplying by the LCD so that we don't have any denominators left to work with. Now also, there are 2 formats here. One of them has the literal equation solved for x so that we find their rate when they work together, and it's given right here. So now that does work. Your first job, though, is to show how it works. So what you're going to do is you're going to take this format right here, you're going to copy this over, and without plugging in any numbers whatsoever for a, b, and x, you're going to multiply by the LCD and clear the fractions, and then solve for x. You're going to be doing some factoring and dividing by the factor that is not the x. And once you're done, this should be your solution. So you start right here and you end right here, but the magic happens in the middle. Now we're going to put that into use. So Tom can paint a fence in 8 hours. Hal can paint the same fence in 5 hours. How long would it take to put 2 coats of paint on the fence? So we're going to start off with our original formula. One of the 2 options. I'm going to pick the one that requires me to say 1 over Tom plus 1 over Huck. And then that's equal to, now remember they're not painting the house once but twice, and when they work together. Now you need to insert some numbers for Tom, how long it takes him to paint the fence, how long it takes Huck to paint it, and how long it takes for them to work together. Now we don't have a number for how long it takes them to work together yet. That's what you're going to find. But again, you're going to replace this together with an x. You're going to multiply by the LCD of Tom, by Huck, and by x. Kim and Josh can clean a house together in 4 hours. So we have a Kim rate, and we have a Josh rate, and then we have working together. Now, the difference in this problem is that usually then we have to find how fast it takes them to work together, but this time we're given how fast it takes them to work together. So we already have a together, we already have a Kim, and then Josh is the one that we need to solve for. You're still going to use the same process, it's just that Josh will be the variable instead of together being the variable. You're still going to multiply by the LCD and clear the fractions. Now, something that changes in number 4 is that we have 3 people working together now instead of just 2. We're still going to use the same format. We're going to use 1 over A plus 1 over B is equal to plus 1 over C is equal to 1 over X. Now that we have 3 people working together, we just have this format. It's not going to be very much different so far. So it's 1 over Jack plus 1 over Mike plus 1 over Chris equals 1 over when they work together, and we'll make that an x. Substitute numbers for Jack and Mike and Chris, and then find the LCD of Jack, Mike, Chris, and x, and then solve for x. By the way, clearing the fractions is something that we can only use when we're talking about equations. See how I have an equal sign here? The only reason I'm allowed to multiply everything by an LCD and clear those fractions out as opposed to using a common denominator is because I can multiply both sides of an equation because I have an equation. Now, an erroneous assumption that students often make is that if I have two people working together, if I take the product of those two people as my numerator and the sum of those two people as my denominator, then I'm going to find that x. Now, that works when you have two people, but it's not true when you have three people. So your first job is to do something that is incorrect on purpose. Your job is to plug in the numbers A, B, and C for Mike, Chris, and Jack from the previous problem and show that this does not equal the answer from number 4. So it's not going to work. So explore that a little bit, and then you have this formula right here. That's the one that you were given from the previous problem, and solve for x. Now, what that means is, again, they don't want you to use the numbers for A, B, and C for Jack, Mike, and Chris, but instead, they just want you to leave them as A, B, and C multiplied by the LCD. The LCD here would have to be A, B, C, x, multiplied by that, and then clear the fractions. So we're going to clear all those fractions, and then you're going to have some sort of lovely x equals, and then a whole bunch of stuff here that has A's, B's, C's in it, but it's not going to be the same thing as this thing right here. This is not true, but you will find the right x equals. And now that you've done such a good job with that, finding what x is equal to, then you apply it right here. So in this spot, then now you'll be able to substitute for A, B, and C, but you'll have a slightly different formula.